Okay, we've hinted at it enough, but we should actually state it. There is a theorem, which I guess I'll just call it the orthogonal vectors theorem. I don't know if that's the official name for it. But the angle between two vectors, A and B, so that angle, let's call it theta, that angle is pi over 2 radians if and only if A dot B equals the zero scalar. So we just use this theorem. We're not going to prove it. If you'd like to, you can say that this theorem is an automatic consequence of a more general theorem that's called the cosine angle formula. By the way, let's present that cosine angle formula. So there's a generalization. So the theorem we just looked at is an if and only if for when the angle is pi over 2. Now there's actually a general way to compute the angle. So what actually happens is that if we use theta to represent the angle between the two vectors, right? No matter where the two vectors are, even if they're not position vectors, if you just slide the vectors around and you don't tilt them, you just move them so that they're position vectors, so that, or at least so that they start at the same place. The angle between the vectors should remain the same if you don't change the tilt of the two vectors. And in order to find out what the angle is exactly, there is this formula. It turns out that if theta is the angle made between the two arrows, then cosine of that angle equals this fraction here. So it involves the dot product that we saw earlier. So in the numerator, dot the two vectors. In the denominator, you have the product of the magnitudes of the two vectors. So we'll skip the proofs of both of these. If you believe the cosine angle formula, you can easily prove the orthogonal vectors theorem. You just need to know something about cosine values on the unit circle, to be honest. If you'd like to prove the cosine angle formula, it comes from the law of cosines, which is a theorem from trigonometry. But we won't go through all of it. You're never going to be quizzed on it. I would, to be truly honest, just memorize this cosine angle formula. Okay, so with this cosine angle formula, let us practice it by answering this question. Let's find the angle between the vector u, which is 3, comma 10, comma negative 1 in angle brackets, and the vector a, which is 2I plus j minus k, written in, well, that other form. I did this intentionally. It's kind of funny business, but the two vectors are presented using different notations. And I guess the point is to convert it into whichever notation you like, right? So for instance, if you want to, you could write the vector a as angle bracket 2, 1, negative 1, close angle bracket. And so if you go through and just plug in all the pieces, you've got a dot product in the numerator, and then you have, magnitude times the other vector's magnitude in the denominator. This is what you get. This looks like madness, and I really don't feel like simplifying. Now, if you want the angle itself, well, so okay, I did, I guess, simplify, I forgot, using a calculator. I wouldn't need you to simplify here. I just wanted the slide to not be too busy. To get the angle, I guess we're just going to need, cosine inverse or arc cosine. So there you go. That'll work for us anyway for the angle.